Hey y'all, we are picking up in this video where the last video left off. So in the last video, we talked about what a logarithm is. And if you haven't watched that and also don't have a solid understanding of what a logarithm is, I highly recommend you start with that video. But if you already understand what a logarithm is, you're in a great place because in this video, we are going to talk about converting between logarithmic and exponential forms. So as you should already know by this point, a logarithm is just a different way of writing an exponent, where we're essentially writing a function that searches for the exponent instead of using an exponent to get to an answer. And as I also mentioned in the last video, logarithms and exponential functions are inverses of each other, okay, which means they're the opposite. So the input and output have been switched, right? And you can see that here, where the a and x are on opposite sides of the equation in the logarithmic form. Putting in a brings you out x. In the exponential, putting in x brings you out a. Okay. The way this logarithm reads, you can see here it says read as log base b of a is equal to x. And what this is asking is b to what power gets me a? All right, so if b to what power gets me a, what I like to think is I start with b and I do something, I put some power in there, and that gets me to a. And the power is what's on the other side, okay? Because that's what the function was asking in the first place, right? B to what power? B to the x power gets me to a. And so in essence, that's how I would start thinking about rewriting. Okay, and again, just to clarify terminology, remember b is the base, so both logarithms and exponents have bases. We use b to represent both of them. The base of an exponential is the number being raised to a power. The base of the log is the subscript that we put when we do log base b. A is the log number, so how do I get from b to a? And x is going to be the exponent. So again, in an exponential form, you see it in the exponent spot, and in logarithmic form, the exponent is your answer. On this slide, we're going to practice writing equations that are given in logarithmic form and writing them in exponential form. So the way I do this, instead of just trying to think or memorize where the numbers all fit, which is going to be hard and you're not going to remember how to do that in the long term, I like to think about what what a logarithm is, so that helps me convert into exponential form. So remember that a log is asking me how do I get from the base to that log number. So what exponent does it take me to get from 3 to 9? And then this is my answer. That is my exponent. So if I'm looking to get from 3 to 9, right, how does 3 on the left become 9? I raise it to the second power. Okay. And that's how I tend to think about it. And this would be your answer, right? Because you're not solving anything, you're just looking to rewrite. So you're looking to rewrite in exponential form. I now have 3 to the exponent of 2 equals a number. That is exponential form. Looking at number 2, it's log base 6 of 216 equals 3. So what that is asking is how did I get from 6 to 216? So I did something to this 6 to give me a result of 216. And what I had to do to the 6 is I raise it to the third power. Moving on to number 3, log base 7 of 1. Well, how did I get from 7 to 1? I had to raise 7 to the 0th power. Looking at number 4, again, how did I get from 2 to 16? Well, to get from 2 to 16, the exponent I had to put to the 2 is a 4. And then numbers 5 and 6 have these fractions in them. Please know that you treat this the same way. These numbers never change, so you're not going to switch the sign. You're not going to take the reciprocal of fractions. You're going to leave the numbers exactly the same. They're just moving positions, just like the whole numbers did. So even if it's a negative or a fraction, you still don't change the number at all. So here I'm thinking about how do I get from 4 to 1/16? So I take 4 to some exponent is going to equal 1/16. And that exponent is -2. And then my last example here asks me how do I get from 9 to 27? 9 to some exponent is going to give me 27, and that exponent happens to be 3/2. Okay. On this slide, we are going to do the opposite of what we did on the last slide. So the last slide was converting logarithms into exponents, and now we're going to take exponential equations and turn them into logarithms. So I'm going to be thinking backwards here. So when I'm given an exponent, it's saying 2 to the second power is 196. And remember that in log form, my exponent is my answer, right? So I'm going to note that my exponent is my answer, so that's going to be on the right side. Left side, I'm going to have the log of something. So what a log asks is, how do I get from one thing to the next? And it's going to be raising something to an exponent. Remember, your base of a log and the base of an exponent are the same. So if my base of the exponent is 14, the base of the log will also be 14. Okay, and I'm looking for the log base 14 of 196, because what this logarithm says is, how do I get from 14 to 196? Well, in my exponential, how did I get from 14 to 196? I had to raise to the second power. Looking at number 8, I basically used an exponent to get me from 3 to 81. So the log is talking about, how do I get from 3 to 81? So log base 3 of 81 is equal to 4, right? Because that exponent is what got me there. At this point, I think it might be wise for you guys to pause the video and try the last 4 on your own and see if you can quiz yourself. And then once you're done, unpause the video, and I'm about to start going over it. So as we start going over number 12, remember a logarithm is, how do I get from something to something else? So basically, how do I get from the left side of my equation, or the side with the exponent, to the side that's just the plain old constant? So in this case, both sides have 12, so it's the log base 12 of 12 is equal to 1, because how did I get from this 12 to the other 12? Well, I had to raise the first 12 to the first power. Moving on to number 10, I'm going to try to explain this one a little different in case that's helpful to you. So remember, because logs and exponents are inverses, my answer will always be the exponent. So I'm going to start with my exponent has to be 1/2. And then as I'm writing the logarithm, right, I'm trying to figure out, how do I get from 36 to 6? So I don't know. I did that backwards. Maybe that was helpful. Maybe it wasn't. Looking at number 11, again, I'm trying to figure out, how do I get from this left side of 2 to the right side of 1/8? I had to raise it to the negative third power. So the log is, how did I get from, or what power takes me from 2 to 1/8? That power is negative 3. And looking here at number 12, logarithm, it's asking what power takes me from something to something else. So what power takes me from 8 to 16, right? From the left to the right, the power, or the exponent, is 4/3. So now that you've completed this video, you should be able to convert between logarithmic form and exponential form. And you should be able to do that regardless of which form you are starting with. So if there's one that is still a little bit more difficult for you, I suggest you rewind, rewatch, maybe quiz yourself again while you're not looking at the answers, and just make sure that you're really solid on this.